In this video, I want to talk to you about sets versus array because this is a question about data structure and it's a commonly asked question during interviews. Alright, so in today's video, we want to explore what are the similarities, what are the differences, and when should we use either when we architect our app. Alright, so let's get started. So sets versus array, they do look very similar. Alright, so as you can see over here, I have an ingredients array, which is a string array that contains 3 elements. So we have water, rice, and milk. And on line 7, I declare a sets string array. Again, I call this ingredients set A. And this also contains the 3 similar elements, okay? Water, rice, and milk. Alright, so notice that the way you declare it is slightly different. We use the square brackets for an array, and for sets we use the angle brackets. So the first thing is that what is common between sets and array is that both of them are value type. So value type means they are copies instead of being linked via a pointer. So let me illustrate what I mean by that. So over here I declare another variable called ingredients set B with the same signature, and I point that to ingredients set A. Alright, so I'm going to add a new element inside ingredient set B. Okay, I'm going to include something that is unique, which is flour. Alright, so notice I don't have flour in the existing list over here. And then if I'm to print out ingredient set A, notice that ingredient set A is left. Okay, let me just comment this out first so that we don't get those additional printouts over here. So if I'm to print out ingredient set A, notice that I'm going to see water, rice, and milk. However, if I'm to print out ingredient set B, I'm going to get the additional flour inside over here. All right. And if this had been a reference type instead of a value type, then ingredient set A would reflect the same elements inside ingredient set B. But notice that they are not, and therefore they are unique copies, all right, rather than being a pointer to each other. So now let's talk about the differences, okay? So we have the first difference is that sets is an unordered list, all right? So as you know, an array is an ordered list. So as you can see over here, very simply, that we have water, rice, milk, and when we add flour inside, notice that we get flour, water, rice, milk. Okay, this happens to be ordered. If I'm to hit the play button one more time, you'll notice that the order will be different. Water, flour, milk, rice. If I hit it one more time, it'll be different again. All right, water, flour, milk, rice. And this is to illustrate that the order is actually random. Okay, so sets is an unordered list. Okay, the next difference is that set contains unique elements. Okay, so let me just illustrate to you. So over here I have an enum ingredients that contains all these elements: water, rice, milk, flour, baking powder, and eggs. And I'm going to declare a cake recipe. All right, so cake would contain these ingredients. Okay, so I'm going to add in these 5 elements inside: water, rice, milk, flour, and baking powder. And I'm going to print out the elements inside the cake recipe and also the count. Okay, so let's hit the play button and notice that we should see those 5 ingredients being printed out: rice, flour, milk, water, and baking powder, and we have a count of 5. All right, so now using the same cake recipe, I'm going to insert the similar elements inside over here, which is baking powder and flour. All right, so let me just uncomment this out, and I'm going to uncomment this out again. So let's see what does this print out this time. Okay, so it's going to print out the same thing because baking powder and flour are already contained within the list over here. Okay, baking powder and flour. However, if I'm to insert sorry guys, this is something that I forgot to mention. To add an element into the list on the array, we use the append method, but obviously as you can see here, when we use a set, we use the insert method over here. So over here in the cake recipe, if I'm to insert a new element, a new unique element, which is called eggs over here, let me just hit this one more time and notice that the count will be 6 this time because this is unique. All right, so I hope that this is easy to understand. Okay, one more thing over here is that sets contain functions to compare elements among 2 sets. For example, you want to do some kind of filtering. So over here, let me declare a new recipe. Okay, so previously we have the cake recipe, and right now we have the cookie recipe that contains baking powder, flour, and eggs. All right, so this is a subset of what cake has. Okay, and we can actually filter out what are the similar ingredients between those two lists by using a function called intersection. Okay, so this is a native method from Swift, so this is really convenient. You don't have to write your own parsing logic. So if I'm to do that, notice that this would list down to me what are the ingredients that is both common between the cookies as well as the eggs. Conversely, I can create I can also filter out the differences, okay, by using this function called symmetric differences. So what are the differences between cookie recipe and cake recipe would be the other two elements. Okay, so let me see what those are. So for the cookie, I have baking powder, flour, and eggs. Baking powder, flour, and eggs. Okay, so the differences would be milk, rice, and water. Okay, so let's check it out. So let's hit the play button again. I should see milk, rice, and water again. You can see that the list is unordered. All right, so I want to show you an application over here of using sets versus an array. And one common application is, okay, sorry guys, forgot to mention one point over here. Difference number 4 is that sets element conform to the hashable protocol, and therefore if you're working with a very large data set, it's better to use a set because it's optimized for data lookup. Okay, so let me provide a simple illustration over here for an application. Okay, so let's assume that we have some elements that we are listing on an e-commerce shop, for example. Okay, so I have this object here called review. So we can have a good review, a medium review, or a low review. Okay, I just call this high, and then I declare a strut over here. So let's think of this as, you know, products on Amazon. Okay, so we have the name, we have the review, whether it's high, medium, or low, and we have the price. So I'm keeping this example really simple. Okay, so over here I have some elements here, some items here, and the names over here is not so important. Okay, but I want to have a bunch of elements inside this array. Okay, so right now what I'm going to do is that I'm going to declare two sets over here. So I'm going to use cheap and good. Okay, so cheap is a set of items, and I'm going to filter this where the price is less than $7. All right, so anything that's less than $7, I consider this to be cheap. And what is good is all reviews that are rated as high. Okay, so now when a user performs a filter, for example, they want to set the price to be less than $7 and they want the review to be high, we can therefore get the results by doing an intersection between what's cheap and what's good. All right, so as you can see over here, when we finally printed this out, you know, we love cheap and good stuff. Okay, it's not very obvious over here. So this is basically how we can actually do filtering by using a set. Okay, all right, so right now I want to come to the summary of this presentation. So the first common trait is that both of them are value types, and the first difference is that set is unordered, set contains unique elements, and set contains inbuilt functions for comparing and filtering elements between two sets. And when should you use a set? So you want to use a set if order does not matter and uniqueness is important, and when you are working with a large data set. Alright guys, I've come to the end of the video, and I hope that you have learned something from it, and I'll see you in the next one. Cheers, bye.